Once we have understood thermal energy reservoirs, now let us move to heat engines. Okay, so what exactly are heat engines? So uh, thermodynamics itself means thermi plus dynamics, that means you are converting heat to work. So heat engine is a device from which you in which you can convert this heat to work. So you have a high temperature source. See, for any heat engine, you have a high temperature source, that is a thermal energy reservoir. Yes, and then you have the heat engine. Then you have the low temperature sink. So you can extract heat from the high temperature source, that is Q in, and you can reject Q out to the low temperatures. And you can also extract from, you can see that you will extract a work, that is, this is the net work out. So heat engine takes in Q in and produces work and then rejects the rest of the heat to the low temperature sink. Okay, and if you apply, so if you apply the first law of thermodynamics, you can easily find out that net work output is equal to Q in minus Q out. There is no in other any other energy exchange here. There is only Q in and Q out and W net out. So according to first law of thermodynamics, W net out is equal to Q in minus Q out. Now what is the efficiency of a heat engine? Efficiency of a heat engine is just defined as the output by input. So output is your work produced and input is the Q in. This is the energy you are supplying. Okay, so this is all about heat engine. Okay, heat engine is a device used to produce work from heat. Okay, you can see that for any heat engine you need to absorb heat and reject it. We will see why this Q out cannot be zero. So when you study second law of thermodynamics, we will explain why, because we need to reject some amount of heat, otherwise it will violate the second law of thermodynamics. Okay, so understand thermal second law of thermodynamics, we need to first understand what is heat engine. Now we will look at a practical heat engine. A practical heat engine. Okay, one more thing. See this heat engine. Okay, any heat engine will work in a cycle. Okay, see, this will work in a cycle. For a heat engine, you will have some kind of a fluid. That means you will have either water will be the fluid or air will be the fluid, and this fluid, see, completes a cycle, because initially it will be at a state 1, so it will undergo a cycle and finally reaches this point, right? So this is a cycle. Now let us take the example of a steam power plant, which is a heat engine. In steam power plant, you can see that you have an energy source such as furnace, which can be assumed to be a thermal energy reservoir, from which you are extracting heat Q in. Okay, so you have the boiler here. In boiler, you have water. This water will be converted to evaporates into steam in this boiler, and this steam is passed to a turbine. Okay, so this is your system boundary. All these devices come under the system boundary. So this is arbitrary boundary. So this steam passes through the turbine. High speed steam passes through the turbine. It produces, from turbine you are extracting work, that is W out. And during this process some of the steam condenses, and this condensed steam, so the rest of the steam passes through the condenser, so where which will be totally condensed. Energy is released. There is energy released to the energy sink, such as atmosphere or lake, etc. Because this is another thermal energy reservoir, heat is released, and then this water is again pumped back to this boiler. So in order to pump it back to the boiler, you need to supply a work, that is W in. Okay, so this completes a cycle, because initially here water will be a liquid. Okay, so after all these processes it will come back to its initial state. Again it is boiled and becomes steam. Steam passes through turbine, you extract work and rest steam, and then steam passes through condenser, then it through a pump, finally it will reach the liquid state. Okay, so that means this system undergoes a cycle. Okay, so this is a perfect example of heat engine. Okay, that means, so this works in a cycle. It takes in heat Q in, produces work out W out, and rejects heat Q out. Okay, so steam power plant is a perfect example of a heat engine. So you can see that here net work output is equal to, so you are getting a work output here, but you need to supply a W in here, a pump. So net work output is equal to W out minus W in, and Q net, so net heat transfer here will be equal to Q in minus Q out. Okay, so according to first law of thermodynamics, for a cyclic process, you know that Q is equal to cyclic integral of Q is equal to cyclic integral of W. So W net is equal to Q net. So that means W out minus W in is equal to Q in minus Q out. So this is all about steam power plant. This is the this so this is an example of a heat engine.